So next, what I want to do is I want to talk about how to solve for the terms of trade in the general Ricardian model. So this is going to use all of the same methods we've seen as before, using just the example that we just did. But it's good practice to do this again. But in particular, I think this section will be particularly helpful as a quick reference for when you want to go back to thinking about, especially to prepare for the exam, you're sort of asking yourself, okay, what did I have to know about how to solve for export supply and import demand curves? And so I think this will be particularly helpful as a quick reference. So just a quick recap of the Ricardian model. We've got two countries, home and foreign, denoted by star, and two goods. Let's just call them 1 and 2. The assumptions of the model that we're always going to have is going to be that labor is perfectly mobile across industries, but cannot move across countries. We're going to have perfectly competitive labor and goods markets, which those two assumptions are going to give us that in autarky, wages must be paid the same, and also wages must be equal to each sector's marginal revenue product of labor. And then we're also going to have that consumer preferences must be identical across countries. So in this case, we're going to assume that preferences are going to be identical, and consumers are going to have preferences over goods be given by Q1 raised to the alpha and Q2 raised to the 1 minus alpha, where you can assume that alpha is something in between 0 and 1. And so from just the Cobb-Douglas general solution for demand that comes from section 1, exercise 4, we're going to note that consumers are just going to spend alpha % of their income on expenditures on good 1, and the remaining 1 minus alpha % of their income on expenditures on good 2. Production functions in the Ricardian model are linear, and they're just given by y1 is equal to a1 times L1. I here just represents the country, and y2 being derived the same way. Endowment of labor in both countries, recall it's just given by L bar and L bar star. And then the labor market conditions are just given by L1 plus L2 must equal to L bar, and same for foreign. And in other words, this is just saying we have full employment. There's only two sectors of our economy, so our whole population is either going to work in sector 1 or sector 2. There's no other alternative, and you can't be unemployed. Okay, so at equilibrium, you would think that it would be a reasonable condition to think that world demand is equal to world supply for each of our two goods. And so this is what's going to pin down prices in the Ricardian model. And this is going to be called a goods market clearing condition. Of course, you might you're welcome to use those expressions for world demand for 1 equal to world supply of 1 to figure out what prices are. Doing so would get you the correct answer. But just to make it a little bit more intuitive, you can just rewrite those to get the home export supply equals foreign import demand equations. But it's worth noting that however you remember them, they're the exact same condition, and so you can derive them in whatever way is easiest for you. So let's consider the goods market clearing condition for good 2. So this is just the goods market clearing condition. And let's consider the example from before. So let's focus on good 2. So what is the goods market clearing condition? It just says that if we think about good 2, and we think about consumption of good 2 by home, and consumption of good 2 by foreign, if we think of production of good 2 at home and production of good 2 in foreign, then this is going to be total supply of good 2. And total supply of good 2 just must be equal to total demand for good 2, where each of these is each country's consumption of good 2. So this is total demand for good 2. Okay? But note that all I can do here is if I subtract Q2 on both sides. So if I subtract Q2 on both sides, these cancel, okay? And then if I subtract Y2 star on both sides, then these cancel. And so what I'm left with is I'm left with Y2 minus Q2 is equal to Q2 star minus Y2 star. And so if you recall, this is just Home's export supply. So this is Home's export supply. And this is foreign's import demand for good 2. Okay, what if it's really foreign who's exporting good 2 and home who's importing? Well then these equations would still be correct. Like this part would still pin down the equilibrium, but in order to make everything the right sign, we would just have to multiply on both sides by -1 to make sure that we have the right person importing and exporting. Recall that this is defined to be exports as long as it's greater than 0, and this is defined to be imports as long as it's greater than 0. If it's less than 0, then it's not imports, it's exports. And likewise for foreign's export supply. Okay, so as I said, if home exports good 1 to foreign instead, you just need to multiply these above equations by -1, and then instead of home's import demand for good 1, it would be home's export supply of good 1, foreign's import demand of good 1. Okay, so this just shows that there's a variety of different ways of thinking about these equilibrium conditions which are going to pin down our prices. We can either think about world demand for one good and solve for prices equaling world supply, or we can think about export supply of one good equaling import demand for one good. And notice that we only need to solve for one good to figure out prices. We don't need to figure out both goods to figure out prices. So like the example before, suppose home specializes in good 2 and foreign specializes in good 1. Then complete specialization implies that income in both countries is just a function of what good it chooses to produce. So then if we just go back to their each country's optimal demand, then what we'll have, and if you give me a minute to erase all this stuff, well, note that, home has a CA in 2, foreign in 1. So what does that mean? That implies that home's income is only going to be a function of their production of good 2. Foreign's income, excuse me, I'm going to use a little bit different notation. Foreign's income is just going to be a function of the price of good 1 times their production of good 1. And so then, if we just want to figure out what home's consumption of good 1 is, well, note that with Cobb-Douglas references, they're going to consume alpha percentage of their income on expenditures on good 1. So that's what this expression says. Or likewise, Q1 is equal to alpha times I over P1. But just plugging in P1, then what we'll get is that Q1 is equal to, and actually, sorry, I'm going to write this on a new line. Q1 is going to be equal to alpha P2 over Y2 all over P1. Okay, and then Q2, well, likewise, it's going to be 1 minus alpha I over P2. Hopefully you can sort of see that pattern. And then, again, if we just plug in for I here, now we get that Q2 is going to be equal to 1 minus alpha P2 Y2 over P2. And so this just, what does this simplify down to? This just simplifies down to 1 minus alpha times Y2. Okay, we can do the same for foreign. Note that it all looks very similar for foreign, so everything is going to be the same except for just replacing everything with stars to denote that it's a foreign outcome. Well, so here instead foreign's income is the only thing that's different, and so this is going to be P1 over Y1 star over P1, and so what do we get? We got that this is equal to alpha times Y1 star. Foreign's consumption of Q2, likewise, well, we can drag all of this over. This is all the same. 1 minus alpha. Remember that countries have identical preferences here. The only thing we replace is that we're now talking about foreign's income. And so likewise, we're just going to plug in for foreign's income, which we know is only a function of good 1. And so we get that foreign's consumption is described by this. Okay, and that's what these expressions say right here. The only thing to note is that these just flip everything. So it's a function of the relative price that they face. So for instance, for foreign's production, or sorry, foreign's consumption of good 2, we just want to have it written in terms of the relative price of good 2 over good 1, so we can graph it more easily when we want to graph foreign's import demand as we did before. But it really doesn't matter. It's the same thing either way. Okay, and so now what we want to do is we want to now just figure out what home's export supply and foreign import demand is going to be for good 2. So let me just go back. I fortunately didn't erase anything. So let's think about home's export demand, or sorry, home's export supply. Okay, for good 2. So what's home's export supply? What is X2? Well, that's just going to be equal to the amount they produce of good 2 minus Q2. Okay, and so recall that Q2 right up above there is 1 minus alpha times Y2. So I just have that this is Y2 minus 1 minus alpha Y2. And so this is just going to be equal to, well, I'll make sure I do out all the math. This is just going to be equal to Y2 minus Y2 plus alpha Y2. These cancel, and so foreign's exports of good 2 are just going to come down to alpha times Y2. So that's a very similar result that we saw before. With Cobb-Douglas preferences, the production or the exports, home's always going to export a constant number of the good that it specializes in. So that's, as you can see, a general result coming from Cobb-Douglas preferences. We can simplify this further. Note that if we have full specialization, then recall that Y2 is just a sidebar. Y2 is just equal to A2 times L bar, since home puts all of its workers to work in industry 2 here. So we can simplify this further and just say Y2 is going to be really equal to A2 times L. Okay, what's foreign's import demand for good 2? Well, it's just equal to their consumption less their production. They're fully specialized, so notice that this is 0. And so foreign's import demand is just going to be equal to and note that this is all assuming full specialization. It's just going to be equal to whatever their consumption demand is. So recall that that's 1 minus alpha times P1 over P2 times Y1 star. And so just to make this really sort of simplify down to fundamentals of the model, I'm just going to plug in for Y1 star there, just how I did for foreign's export demand. And note that Y1 star, we know that foreign isn't going to produce any of good 2, so it's just going to be equal to A1 times foreign's full population. Okay, so this is foreign import demand and this is going to be home export supply. Okay, so getting back to the slides, if we set these now equal, let's figure out what assuming that we have full specialization, let's figure out what that implies for relative prices. Okay, so essentially what we want to do is we want to set x2 equal to m2, or we want to set home's export supply equal to foreign's import demand. Okay, so what's x2? Well, it's just alpha times a2 L bar, and then what's this? Well, this just comes down, and then it's equal to 1 minus alpha P1 over P2 A1 over L bar star. Okay, so all I'm going to do is I'm going to divide by A alpha times A2 times L bar on both sides. I'm going to do the same here. And just divide by alpha here. And then I'm going to cross multiply by P2 over P1, both sides, or P2, excuse me, for P1. Note that these cancel. And so what do we get left with? P2 over P1. And so this is going to be the equilibrium, assuming that both countries are fully specialized or that prices follow P2 over P1 world is less than the autarky price in foreign. So this is, again, assuming full specialization. Then what we'll have is that P2 star over P1 star. And sorry, by star I don't mean the foreign price. I mean this is going to be the equilibrium price. So let me rephrase that a little bit. P2 equilibrium over P1 equilibrium. Well, that's going to be equal to 1 minus alpha over alpha times A1 L bar star over A2 L bar. Okay, and so that's should be what we have on the slides, and it looks like it is. But so recall that I said that is only going to hold if we know that both countries are fully specializing. Okay, but it might be the case that one country, the world price might be might actually not be strictly in between those two prices, and so we might actually have that one country, when it opens up to trade, it faces world prices that are exactly equal to its autarky price. In which case we would never have that that world prices would equilibrium world prices would be less than one country's autarky price, and so this reflects that. It reflects that if both countries are fully specializing, we can solve for the price very easily. However, if we find that this price assuming that they're both fully specializing, this equilibrium price is less than Ohm's autarky price. We would never actually have a world price that's going to be less than Ohm's autarky price, and so the equilibrium price is just going to be equal to exactly Ohm's autarky price. Likewise, if we find that this, if we solve for this price, this value, and this value turns out to be higher, and sorry, this is the value here, so you can see that this is the value here. If this value turns out to be higher than Forin's autarky price, then we'd never go above Forin's autarky price, and what the free trade equilibrium would be is that we're exactly at Forin's autarky price. And so hopefully going through all of that in a little bit more general detail helps you see a little bit more of the dynamics. So it's worth mentioning that we went through all of these cases to trace out Ohm's export supply and Forin's import demand, but notice that at the intersection, prices will never be higher than either one of the, or lower than either one of the two. They'll always be in between, weakly in between the two autarky prices in both countries. Okay, so that's all I have. Thanks, and see everyone in a couple weeks.